Today we are going to discuss fundamental products of sets, right? How we product the sets, right? Let's say if you have only one set, right? Before explain this theory, right? I will tell some basics, right? So you have a Venn diagram. This is your universal set. Let's say you have only one set A, right? Based on this fundamental product concept, right? If you have a number of sets, let's say if you have a n number of sets, if you have uh, n number of sets, then 2 to the power n number of products you can find out, right? So if you have a n number of different sets, you can find out 2 to the power n number of 2 to the power n number of products of the set, right? It means, let's say if you have only one set, so n is equal to 1, then 2 to the power n means what? 2 to the power 1, right? It is equal to 2. So it means you will find out two sets as a product, right? What are the two sets? One set, this area, right? This is a one set, right? This, the circle area, we can say one set, one portion, one unique set. The remaining area. So remaining area means what? This one. This area we can say another set, right? So in this situation, right, we can say this one, we can say A is a one product. So this is, we can say A, right? This area we can say A complement, right? So we have two products. A, we will not, we will symbolically represent product as a this symbol, right? This one, right? Intersection symbol. A, this is A complement is another uh, product, right? So these are the two things, right? Similarly, if you have a two sets, two different sets, so n is equal to 2, then 2 to the power n is equal to 2 to the power 2. There are four sets, right? If you have a two different sets, you can find out four uh, four elements as a product of these sets, right? How we can explain this one? Okay, just look at here, the previous example, right? You have two sets, A and B, right? This is A, this is B, this is your universal set. So now tell me what are the areas you have? One area is this area, right? So this is one area. Another one, this area, right? So this is another area, right? The last, this one, two, this area we can say third one, right? Third, outside we have one area, right? So altogether four different components, right? Four different portion when we are plotting a Venn diagram, right? So now tell me, we can say this area, let's say this, we can say 1, this is 2, this is 3, this is 4, right? So first one we can say what? So how we can explain this one? How we can explain? Maybe you can think this is A1, this is A2, right? So you have n number of different sets, then you can find out 2 to the power n number of different sub elements in the products of sets, right? So the first one is what? So this area, how
A
you can
minus
explain this
B.
area?
A minus B.
Very good. A minus B, right? Maybe here, second one, we can say B minus A, right? Third one, A intersection B, right? Fourth one, A complement union of B complement, right? See, these are the four sub elements if you have two different sets, right? So we can say A difference B intersection B difference A. If you write a product of these sets this way, right? So A intersection B, then here A complement union of B complement. Do you understand the fourth one? A complements means the outside of this one, right? Union of B complement of this one means Here, this is A complement intersection B complement, right? So A complement means outside A. Also, you need to find out the common thing of outside of B, right? If you look at here, this is A1, this is A2. Maybe this one is a A1, this is A2. Rather than I'm putting as a, this is a B, right? So then I can say this one is a B, right? This is A, right? So A complement means outside this area, right? Outside A, right? Outside A. Similarly, B complements means outside B. So what is the common area for both? So you can omit this one and this one. Then this, the outside the area, we can say A complement intersection of B complement. This is if you have two sets, right? Similarly, can you write for three sets? Let's say if you have this is, we can call products, right? If you have a three sets, let's say A1, A2, and A3, can you write how many portions you have? 2 to the power 3, then 8 portions, right? 1, 2, 3, 4, 5, 6, 7, outside 8. Can you write all the 8 portions in the set notations? Similarly, how you can write for these 8? Can you try that one? How you can write? Try this. How you can write? So the fundamental products of set what says maybe the each portion, each portion of the product maybe uh, becomes an A or becomes a complement, right? One of these, right? Maybe it becomes A means that set or complement of that set. These are the two possible options for these, right? So how you can write for if you have three sets? Okay. Also, you can check with your answers, right? I will write the answer. Just check with yours, right? The important thing, if you know the set notations, you can write all the set areas, right? All the product areas by using a set notations, right? So I consider this is A1, right? This is A2, right? The third one, this is A3. So this is my universal set. So I am giving a number for each area. So 1 means this one, this area, right? 2, 3, 4, 5, 6, 7, outside 8, right? So if I need to write all the 8 areas as a product of this set, how we can write? First, we will find out what are the 8 set areas, 8 sets, right? So first one, how we can say this one? How we can say? Intersection of B complement and C complement. Sorry, this is not AB, right? So A1, A2, right? So this is A1 intersection of A2 complement intersection of A3 complement. Can you find out this one? So if you are putting intersection, you need to find out the common areas, right? So what is the common area for A1? So A1 means this entire circle, right? A2 means outside this A2, right? Then A3 complement means outside the A3, right? So which one? So one indicated by this area, right? So if you look at here, this is outside A2, right? That's why we can say A2 complement. This is outside A3. So this is A3 complement. Similarly, A1. So this is one area. The second one, A2 intersection of A1 complement, intersection of A3 complement. This is second area. Third area, A3 intersection of A1 complement, intersection of A2 complement. So this is third area. How about the fourth area? How we can indicate the fourth area? Fourth one, maybe different ways you can notate, right? So one way, A1. So fourth one, how you can write? A1 intersection A3, right? Minus A1 intersection A2 intersection A3. Similarly, you can write fifth and sixth area, right? How about the seventh area? Seventh area means this one, right? So A1 intersection A2 intersection A3. How about the eighth one? Outside this area, how you can write? A1 complement union of B1 complement union of, sorry, A1 complement union of A2 complement union of A3 complement. So these are the 8 areas, right? So you can check here, right? So if you look at here, the P1, so this area, so A union intersection of A1 intersection B2 intersection A3. Sorry, ABC, if you consider ABC are the sets. So the second one, this one, P2, right? So P2, they are explaining maybe different ways you can explain, right? So they are they are not considering differences, right? Only they are using the intersection symbol, right? Then A intersection B means this entire area, right? So A intersection B means this entire area. From this entire area, A intersection B, this entire area. Then intersection C complement. C complement means outside this one. So it will consider only this area, right? So likewise, you can try to practice all the different elements of the set product, right? So here you need to remember three important points, right? So whatever the number of different sets, while you are writing a product of these sets, these are the three uh, uh, results, right? The first one we already discussed, right? If you have a n number of different sets, the product of these sets, we can say number of different portion is equal to m is equal to 2 to the power n number of different products, right? Fundamental products. That is first one. We already know, right? The important thing, right? If you look at here, any two fundamental products of the sets, they are disjoint, right? They are disjoint. The disjoint means what? The intersection of these two elements are empty, right? That is we are understand, right? There is no intersection, there is no common elements. That is we can call disjoint, right? So if you look at here, let's say now just consider we have two sets, right? Now we have two sets, A1 and A2, right? So what are the elements of these? What are the four different elements of these products? The first one, we can say A1 complement intersection of, sorry, I put this way, A1 complement here, A2 complement, right? This is the outside area. The next one, A1 intersection A2. The third one, the common element of A into A1 intersection A1 complement. The fourth one A2 and intersection A2 complement, right? Sorry, here A1 A2 complement, here A2 A1 complement, right? So these are the maybe different ways you can explain these four areas, right? So A1 complement intersection of A2 complement means what? A1 complement and A2 complement, the common area, the union of, the intersection of A1 complement and A2 complement, this area, right? So this is this area. If you think about A1 intersection of A2 means this area. Now tell me, is there any common elements between these blue colored area and red colored area? No, right? So it means these two are disjoint, right? Similarly, not only this one, all the areas are internally, each and every portion is disjoint, right? Similarly, if you look at these two, what is this one? Intersection of A1. Intersection of A1 means this entire area, and A2 complement means this outside area. So the common area is this one, right? Similarly for here, this area, right? So if you look at check these two, they are also disjoint. So from the product of sets, we can say each and every portion is internally disjoint each others, right? So it means if you write a product of sets, each portion, each element of that product internally disjoint among them, right? There is no common element, right? Even if you look at here, if you have considered three sets, right? So this portion is a separate portion, right? This portion is a separate portion, right? There is no disjoint between this one and this one. This is they are mentioning throughout the second point, right? Now, if you need to find out the universal set of these, all the product of sets, it becomes a U, right? So if you write union with all the portions, we can say that is the universal set. So universal set here is equal to, so the first one, A intersection B, union of A complement, yeah, better, sorry, A1 intersection A2. This is union of the second one, A complement intersection of, sorry, A1 complement intersection of A2 complement, union of A1 intersection A2 complement, union of A2 intersection A1 complement. So if you write union of all the products of these sets, we can say that is the universal set. These are the 3 points, right? You need to remember, right? Any questions? Someone asked a question. Can we write A1 and B2 total complement? A1 and B2 is a total complement. Can you write as a symbolic form? What are you mentioning here? Can we write A1 and B2 total complement, right? So let's say A1, A1 maybe consider A2. A1 and A2 means this one, right? So the total complements means this one, right? So if you're asking this one, just look at here. A1 intersection A2 whole thing complement means which area? Tell me. This is not correct, right? For the fourth one, right? If you don't understand, just draw a circle, draw with the Venn diagram, and you can find out, right? So first you need to find out this is A1, this is A2, right? Then A1 intersection A2 means what? I think you know. A1 intersection A2 means what? This area, right? So the complement of this area means you can omit, sorry, you can omit the intersection area, right? It will consider all this area, right? So is it correct? Wrong, right? So just we are omitting only the intersection. So it means this is intersection means this area, right? The common elements for both sets. So the complement, entire complement means you are omitting only this portion. You consider remaining all the elements in the sets, right? Complement means you need to omit this area, but all the areas in the universal set, right? So if you have A is a set, so the A complement is denoted by how? The elements not belongs to A, but the elements belongs to universal sets, right? Similarly, here A1, A2 means A1, A2 whole thing complement means the elements not belongs to A1 intersection A2, but the elements belongs to universal set, right? So just here we are omitting this one. So is this the fourth product of fourth product elements? Fourth elements of the product is not this one, right? I need this one, right? So fourth product means I need this one, right? I need to omit this area, right? Did you get my point? So from your case, it also include this one as well, right? So it's not the correct answer, right? Yeah, union is equal to A1 union. Yeah, if you yes, yeah. If you write this way, yeah, A1 union A2 means what? If you look at here, A1 and A2 whole union means this area, right? So if you omit complement means you can omit this colored area and you can consider the remaining area. Yeah, this is correct one, right? Okay, this example they are explaining with if you have a three different sets, so you have altogether 8 elements, right? 2 to the power 3 is equal to 8 elements as a product, right? As a fundamental product, we have 8 elements, right? Yeah, it's correct. A1 union A2 whole thing complement. So you are mentioning A1 union A2 whole thing complement. Yeah, it's correct, right? Just you can remember, right? If you write fundamental product of sets, all the elements are internally disjoint, right? There is no common element between each portion of the fundamental product. You need to remember that one, right? You need to remember 2 to the power n number of uh, elements as a product, right? That's the second one. So to find out the universal set in the fundamental product scenario, to find out the universal set, you need to write all the fundamental product element as a union, right? So you can write union of all the portion, right? If you write this way, we can find out the universal set, right? Those are the things you need to remember. Okay. Okay, now we will move for the next topic, algebra of sets, right? We will discuss some principles, some laws related to set theories, right? Already we have discussed some properties related to numbers, right? Yeah, we discuss the similar properties, right? Let's say A plus B is equal to B plus A, right? So A plus B, likewise we discuss while we are discussing some numbers, right? Number laws or number properties, right? Similarly, in the set theory also, we have some set of principles, so set of laws, right? We will look at what are the laws one by one, right? So to define the set of uh, to define these laws, right, we are using three symbols, right? Maybe we are using union, we are using intersection, we are using complement, right? Then we are using the empty set, we are using the universal set. These are the things we are use. These are the notation, set notation. We will define all the sets. The first law says, we can say idempotent laws, right? Idempotent law means, let's imagine you have a set A, right? So the union of same set is what? You have a set A, the union of the same set is equal to A, right? Similarly, you have a set A, intersection of that set is equal to the same set, right? It means nothing, right? If you find out the union of same set, that is the same set, right? If you find out the intersection of the same set, it's also the same set, right? This is the idempotent law, right? Associative law means A union B union C is equal to A union B union C, right? This is similar to 1 plus 2 plus 3 is equal to, this is similar to 1 plus 2 plus 3 is equal to 1 plus 2 plus 3, right? The same idea we'll discuss as a law in the number system. Here we are using the set theory, right? If we have a union of A union B union C is equal to A union whole thing B union C, right? Similarly, this is one portion. Another portion, A intersection B whole thing intersection C is equal to A intersection B intersection C. This is the, we can say, these two we can consider, this pair we can say as a associative law, right? How we can check this one? Okay, I will explain with first one, right? I try to explain first one with the help of Venn diagram, right? If you look at this associative law, just consider the left portion, right? What is the left portion says? A union B union C, right? So if you draw a Venn diagram for these three sets, now tell me A union B is what? If you look at let's say, yeah, I forgot to write the letters, right? Okay, just consider this is A, this is B, this is C. Now tell me, what is A union B? A union B means this one and this one, right? So this is A union B, right? So now they are asking A union B is this area. Then union C means altogether we join this area as well, right? So this is the left portion of the element. So this is explained by this colored area, right? All the colored area we can say A union B union C. Similarly, if you look at the right portion, A union of B union C, right? So similarly, if you draw a Venn diagram for this one, this is A, this is B, this is C. Now tell me, B union C is what? So B union C is B union C is this area. Sorry, I forgot this one. B union C altogether, we can say this area, right? So the union of A. So B union C is this area. Union with A means this area together, right? So all the colored area, we can say A union, whole thing B union C, right? Both are indicated by all the colored areas are same, right? So we can say this is equal to this one, right? Similarly, we can write for this one as well, right? A intersection B intersection C is equal to A intersection B intersection C. This is we can call associative law, right? Similarly, we can say commutative law. Commutative law means the same one. A union B is equal to B union A. Both are correct, right? Similarly, A intersection B is equal to B intersection A, right? This is we can call commutative law. Fourth one, distributive law. Distributive law means A union within parentheses B intersect, sorry, A intersection B union C. Okay, I will explain from this one, right? A union B intersection C is equal to A union B intersection A union C, right? Just we will, this is similar to, we will expand the bracket, right? Let's say if you have an element 2 into 3 plus 5, then we can write what? 2 into 3 plus 2 into 5, right? The similar concept we apply here. Just look at here. So just imagine this is your operation symbol, right? Just we are getting A union, this getting this portion, A union. Then I will write B, right? Similarly, A union C, this is the middle symbol, it comes here, right? Similarly, A intersection B union C is equal to A intersection B union of A intersection C, right? This is we can call distributive law, right? Why we are discussing these laws, right? Some situation to solve, you need to use this type of equation to find out the number of elements, right? We will just look, we will later, we will find out in some questions, we need to find out how many elements in a particular set A. So we can denote it by some symbols. On that situation, you need to use these type of laws, right? If you find out A union B intersection C, some situation, you need to write the long form A union B intersection A union C. Sometimes you need to write these, right? Rather than instead of this one, you need to write this one to find out the answers. That's why we are learning these type of laws, right? So the fourth, the fifth one, identity law. Identity law means you have a set A, right? Similarly, you have a empty set. What is the union of these two sets? The union of A and empty set, that is A, right? Similarly, you have a set A and you have a sort empty set. What is the intersection of these two? That is an empty set, right? If you look at here, the union of a set and the null set, that is becomes A, right? Intersection of these two sets are what? Empty set. Similarly, if you have a set A and you have a set universal set, so the union of these two sets are universal set, right? Similarly, you have a set A as well as universal set. The intersection of these two, it is equal to A, right? So this one, union of universal set and a set A, that is a universal set. Intersection of universal set and a particular set A, that is belongs to that set A, right? This is we can call identity law. The next one, involution law. Involution law means, let's say you have a set A, the complement of complement, we can say the same set, right? This is we can call involution law. A set's complement and to the complement, right? A complement, whole thing complement, it explained by the set A, right? To find out this one, right? Just find out a set A, right? It contain element 1, 2, 3, right? This is universal set. This is universal set contain 4 and 5, right? Now tell me what are the elements for A? A contain 1, 2, and 3. Now tell me what is A complement? A complement is equal to elements not belongs to A but belongs to universal set. So A complement is 4 and 5, right? So now tell me A complements complement, right? A complements means, so now we are consider A complement as a set, right? A whole thing complement means what? So if you consider A complement as a set means 4 and 5 are elements, right? But now you need to consider the elements not belongs to A complement, but belongs to universal set, right? So now here we are consider this as a set, right? Now, so the if you it consider A complement C, so the A complement means the elements are 4 and 5. The complement of A complement means the elements are 1, 2, 3, right? So now if you look at here, we already know, right? A contain elements of 1, 2, 3. Now A complement also consider 1, 2, 3. So we can say A is equal to A complement to the complement, right? Okay, the next one, complement law, right? The previous example we can say involution law, right? Now we will look at complement law, right? Complement law means you have a set A and you have a complement of that set. So union of these two set, we can say that is a universal set, right? Similarly, you have a set A, you have a complement of that set. So the intersection is what? Empty set, right? Easiest thing, just imagine with the Venn diagram, right? You have a set A. So you have, so this is set A. So the outside area, we can say this complement. So union of these two sets are considered as a universal set. Together, this area and this colored area, we can say universal set, right? That is union, right? So intersection means what? The common things. So is there any common things between these two? So this outside, the dotted line area is A complement. This area is A. Is there any common elements? That is intersection, right? So there is no common element between these two. Then we can say the intersection of A and A complement is a empty set, right? This is we can call one portion of the complement law. Similarly, you have a universal set. The complement of universal set, we can say that is also empty set, right? You need to remember, if you look at anywhere, complement of universal set, some maybe you need to replace by empty sets. It's up to your requirements, right? Similarly, if you have an empty set, the complement of empty set becomes a universal set. So you need to remember these, right? This is we can call complement law. The last one, De Morgan's law, right? I think you already learned this law in your O levels, right? De Morgan's law. So just remember this De Morgan's law, right? Sometimes you need to replace or you need to apply this De Morgan's law while you are doing some calculations or while you are doing some questions, answering some questions, right? The De Morgan's law says A union B whole thing complement is equal to A complement intersection B complement. Similarly, A intersection B whole thing complement is equal to A complement union B complement. So easiest way, right? Let's say first I will explain how to remember this one, right? So just look at here, the left portion, right? A union B whole thing complement, right? A union B whole thing complements mean in the right side, you need to write each element as a complement. Just look at here. A union B whole thing complement is equal to, I'm writing right side, A complement and B complement. Here, if you have a union symbol, you need to put intersection symbol. Similarly here, A intersection B whole thing complement means, now again you can write both side complement. Here the symbol is intersection. Now you need to put the symbol union here, right? Sorry, here. So first you need to write the complement of A and B. Then you need to put union here. This is we can call De Morgan's law, right? Okay. With the help of I will explain one portion of the De Morgan's law, right? Okay. Okay, I will explain this one, right? By using a Venn diagram. So now tell me, okay, you have two sets A and B, right? Tell me A union B means this area, right? So now complement of A union B means what? So complement of A union B means this area, right? So this is complement of A union B. This is left hand side, right? Similarly, if you look at the right hand side, just look at here. I try to explain with two sets, right? Now A, this is B. Now tell me what is A complement? What is A complement? So A complements means this is A complement, right? Similarly, tell me what about B complement? B complement means, sorry, okay, this is A, right? Okay, now tell me what is B complement? So B complements means, so this is B complement, right? Now tell me how you can find out the intersection of these two. So intersection of these two means what? The dark green area, right? So what are the dark green area? Dark green area means outside this one and this one. So that's why we are explained here, right? Do you get my point? Green color area is A complement. Orange color area is B complement. So now the right hand side says A complement intersection of B complement, right? It means I need to find out the common elements of this is we can solve intersection, right? Intersection means common elements of A complement and B complement. So it means the dark green area. So the dark green area is the outside area, right? So that is we are getting from here as well, right? So the De Morgan's law is correct, right? This is one way we can explain by using Venn diagram. Another way to prove whatever the laws, right? Just imagine you can find out a set A. A contain element 2, 4, 6, right? B contain elements 1, 3, 5, 6, right? Universal set contains okay. Just you can take an assumption of these sets, right? Then if you need to prove without Venn diagram, right? First you will take some assumptions, right? This is your universal set with elements 1, 2, 3, 4, 5, 6, 7. You have a set A 2, 3, 2, 4, 6. You have a yeah. You have a okay. I will write this way, right? You have a universal set. Okay. You have a universal set with starting from 0, 1, 2, 3, 4, 5, 6. Right? You have set A contain elements you have let's say until yeah until 7, right? You have set A start 0 1 3 5, right? You have a set B 0 2 4 6, right? Now to prove the De Morgan's law. Now I'm planning to prove the De Morgan's law. A union B, all thing complement is equal to A complement intersection B complement, right? This is I need to prove. Right now I take the left hand side. So now tell me what is A union B? What is A union B? So A union B is what? 0, 1, 2, 3, 4, 5, 6. So these are the elements. These are the elements for A union B. Did you get my point? A union B means you need to write all the elements belongs to A and B. If any element duplicates, you can remove, right? So the zero is contains the A both. So I remove 1, 0, right? 0, 1, 2, 3, 4, 5, 6. These are the elements of A union B. Now tell me what is the uh, complement of A union B. Someone tell me what is the complement of A union B. So you need to think the elements not belongs to A union B, but they are belongs to universal set. So if you look at here, A union B contain 0 to 6. Is there any elements belongs to union, but not belongs to A union B? So only the element is 7 is there, right? So A union B whole thing complement is equal to 7, right? This is our left portion, right? Similarly, I need to do for my right portion, right? Now I need to do for my right portion, right? So if I look at my right side, what it says, A complement intersection B complement, right? Now I need to find out what is A complement. Now tell me what is A complement. What are the elements belongs to A complement? A complement means the elements not belongs to A, but they are belongs to universal set. Now tell me uh, if you look at, I will write this. You can say, I will write here, right? Okay, I will write here. Now tell me what is A complement. So A complement means you omit 0, 1, 3, 5, but you need to write remaining elements. So you can omit 0, 1, 3, 5. So A complement belongs to 2, 4, 6, 7, right? Similarly, B complement is equal to B complements. You can omit 0, 2, 4, 6 in the universal set. So the remaining elements are 1, 3, 5, and 7, right? So our right hand side says A complement intersection B complement. It means what? So this is A complement, this is B complement. I need to find out the intersection. Intersection means the common element. So what are the common elements for these two? Only 7 is the common element, right? So we can say 7, right? Now if you look at my left hand side, it contain only 7 as an element. My right hand side also contain only 7 as an element. So we can say the De Morgan's law is correct, right? Similarly, you can prove by using these two ways, right? For all the laws, you can prove by using these two ways. Maybe you can assign some sets. You can assume some sets. Then you can prove this way, or you can draw Venn diagrams and prove. Right? It's up to your facilities or your uh, easiness. Right? Depending on you can choose whatever the way to prove the laws. Right? So these are the laws. Right? So the important law, all other laws are also need, but the De Morgan's law we need to use most of the situation. Just remember the De Morgan's law is what. Not only all the laws you need, especially this law, you need, we apply more places this De Morgan's law, right? Okay, now we will move for, yeah. I think you have a subject called logics, right? Did you learn logics? Logic diagrams, likewise, I think you have some subject, right? Logic design or something, right? Tell me. Okay. So the in the logic, you learn some symbols, right? What do you mean by this symbol? This is not symbol, right? If you have this symbol or symbol, right? If you have this symbol and symbol, right? So these symbols you learn logic, it is similar to the set theory, right? So this not symbols is equal to in set theory, we can say complement, right? This or symbol, we can say union, similar to union, right? This and symbol, we can say intersection symbol, right? So these are the similar symbols in set theory, similar to the logic design. You learn the symbols, right? Also the laws here. What are the laws we are discussed here? Also, you learn those laws in the logic design as well, right? These are the logic laws, I think. Yeah. So the list of laws we discussed previously also are equivalent to the logic laws. Did you learn those laws in your logic theory, logic designing class? Tell me. So if you think about the De Morgan's law, we discussed A intersection B, whole thing complement is equal to A complement union B complement, right? This is De Morgan's law in the set theory. The same law you discuss in the logic class, right? A uh, A and B, whole thing not symbol, it is equal to A union B, right? Did you learn? Did you learn this law in logic design? So this is similar, right? Did you learn? Tell me.
No, sir.
So this, sorry, maybe
Not
somewhere
yet,
you
sir.
can.
No, sir.
Yeah, maybe predicators. There are so many things in logic. Maybe I don't know exactly this semester. So in the upcoming semester, you can learn this type of rules, right? Laws, right? So the same De Morgan's law in the set theory, we can apply in the logic design as well, right? So here, or halting complement, we are using not symbol. Here, A and B are two logic statements or logic components, right? I think A is something called you are defining a logic statement. For B, you are defining a logic statement. Then we apply these laws likewise, right? So the same logic laws we are applying here the set theory as well, right? So yeah, up to this they are explaining those things, right? So duality means if you look at this table, yeah. I delete that one, right? So in the previous table, right, you notice uh, uh, each and every laws, right? Even if you have a De Morgan's law, they have two portions, right? In the table, there are two portions, right? One portion, let's say one portion of the De Morgan's law says, one portion of the De Morgan's law says, A union B, whole thing complement is equal to A complement intersection B complement, right? Duality means here we are using union and complement, right? Here union, here complement, here intersection, right? The symmetric law we can define A here. If it is a union here, we can write here intersection, right? B all thing complement is equal to A complement. Here, if it is an intersection, we are putting union here, right? B complement, right? This is we can call duality, right? Duality means if you have a union as a symbol, sorry, if you have a union as a symbol, you can replace with intersection. If you have a empty set, you can replace with universal set. If you have a universal, you can replace with empty set. You have a intersection, you can replace with union, right? This is duality. If you have a associative role by using intersection, maybe you can create another law by using if intersection, then union. If you have a commutative law by using a union symbol, then you can create another law by using the intersection, right? That is we are called all the laws are set of pairs, right? So that is duality. Duality means if you have one pair, you can create another pair opposite symbol, right? If you look at here, if you are using the union symbol, you can create another law by using the intersection. If you have a law with intersection, you can create a law with the union. If you have a law with universal set, you can create a law with empty set. If you have a law with empty set, you can replace with universal set and create another law, right? If you look at here, this is what one law, right? uh, Not only law, so this is one equation, right? So if you look at here, what is the common elements for universal set and set A? So we already discussed, right? So the common elements of universal set and set A is what? The common thing of universal set and set A, the set A. Here, the final short answer is A, right? The answer is A, right? Similarly for this one, so this let's say if you easiest way draw a Venn diagram, right? So this is universal set, this is A, right? This is B. Now tell me the intersection of union and A is equal to this A, right? Now here they are mentioning B intersection A means this area, right? Now tell me, if you consider here in the middle universal, it is a universal means we can say this belongs to this A, right? This is they are explaining by A, right? Now in the right side, I'm replacing universal set with empty set. This intersection with union, right? A as a same. Here, if it is a universal set, I'm replaced with intersection, right? Now the union is intersection replaced with intersection, right? This intersection with replaced with union, but the answer is same, right? That is we are called duality, right? So now tell me what is the union of empty set and A? That is A, right? So for A and A union B, A union B and A, the common element is A, right? So they are getting the same answer, but whenever you apply duality for whatever the equation, right? Okay, now tell me, uh, okay, now tell me, can you create the duality of this law? A union B intersection of union. So how you can create A intersection B? So here intersection, then we can replace with union of universal set with empty set. So now tell me, what is the answer for this area? A union B and intersection of union. It is equal to, tell me. So if you look at here, right, you have two sets, A and B. So A union B means this colored area, right? For this colored area, and you have a universal set, right? So what is the common element for this one? Did you get my point? So this is your universal set. So what is the common area? Tell me.
A union B.
A union B, right? So now tell me, it is not working. Okay, rather than this one, right? It is not working correctly, right? Okay, A union B. Okay, A complement. Um, okay, I write here A union B, then intersection of A, right? If you apply duality, what will happen? A intersection B, right? Union of A, right? Now, if you check this one, right? So A union B is what? So if you plot here, AB, A union B means this area, right? So A union B this area, then you need to check with A, right? So it belongs to A, right? It belongs to A, right? So this is the left portion. The common elements of A union B and A is equal to this colored area, right? If you look at, if you apply duality, now we need to find out A intersection B, right? So A intersection B means this area, right? So A intersection B is this area, union of A, right? A means this colored area, right? So altogether we are getting the A as a result, right? So don't apply that empty set and universal set. Sometimes if you apply the empty set and universal set, it creates some mistakes, right? So if I ask you to use duality and create an equation, it's better, right? You can use union intersection with some sets rather than using empty set and universal set, right? Sometimes this will give some, it is not always true for empty set, right? So empty set means that is there is no elements, right? So this is similar to whatever the number you divide, 1 over 0 is infinity, right? But 0 over 0, we don't know likewise, right? If you divide it by or 0, there are some infinite, right? In mathematics. Similarly, rather than you are using empty set, better you can create equation whenever you use duality. You can use union, intersection, and complement, right? Don't use empty set, right? But for these laws, it will work correctly with empty set, right? The previous laws in the table, it will work, but not it will correct all the times with duality in empty sets, right? Okay, now we will look at finite set and counting principle, right? Okay, I think you know finite and infinite numbers, right? Finite numbers means what? Infinite numbers means what? Tell me. So similarly here we are learning finite set, right? So all the sets we can divide into two, right? Maybe they are uh, finite sets or infinite sets, right? Now we will look at what is finite set and what is infinite set. All the sets we can divide into two, finite set or infinite set. If it is a finite set means, right, a set which have null set, right? Null set means the set has no elements, right? If a set without elements, we can say that is a finite set. Or the set have exactly a particular number of elements, right? Exactly m number of elements, or exactly you know the number of elements in a set, we can say that is a finite set, right? Infinite set means you don't know how many elements belongs to that particular set. These sets are we can call as a infinite set, right? Now tell me an example of finite set and infinite set. Any volunteer? So all the sets we can categorize into two, finite or infinite sets. Finite sets means if you write a set with empty set, or if you have a find out a set as a null set, that is a finite set. It means you exactly know they don't have any elements for that set, right? That is finite set. Or you know exactly how many elements in that particular set, we can say that is a finite set, right? If you don't know how many elements belong to the set, we can say that is a infinite set, right? Tell me an example. Any volunteer? Tell me a set for finite set. Any volunteer? Tell me a set for finite set. Yeah. Someone says an answer. In his answer, one portion is correct. Even numbers below 10, right? It is not a finite set, right? Even numbers below 10 means maybe it will goes until minus infinity, right? So below 10 means okay, right? It will takes 2, 4, 6, 8, but -2, -4 also consider, right? So if it is a finite set means you need to clearly define, right? Yeah, vowel letters. It is a finite set, right? So if you have a set S, that is a finite set with vowel letters. So we know in English only 5 A, E, I, O, U are the vowel letters. So this is a finite set. Why I'm saying this one? We know exactly 5 elements belongs to this set. Another set names of months in a year, right? So we have only 12 months, right? From January to uh, December. So we know only 12 elements for this set, right? So we can say this is a finite set. Infinite set. Similarly, you are defining a null set, right? Okay, let's say a null set. Yeah. Okay, what is that? Let's say I'm telling a set, right? Even number, even number. Yeah. Okay, I'm saying that positive integer, right? Positive integer, even number between 1 and 2. Is there any even positive integer between 1 and 2? No, right? So that is an empty set. So empty set also considered as a finite set. Also, if you know a set that have exactly a particular number of elements, right? Yeah, integer is an infinite set, right? So if you know the exact number of elements in a particular set, we can say that's a finite set. Similarly, if you have an empty set, we can say that is also considered as a finite set, right? Okay, if infinite set means a positive integer, we don't know exactly how many elements for finite set, right? Always we are using for denoted by dot line, right? It means we don't know exactly how many elements, right? So these type of sets we can say by infinite sets, right? If you look at here, they are mentioning, right? Set A, the letters of English alphabet. We know in English alphabet, we have only 26 letters, right? From A to Z, right? So altogether, we know exactly 26 elements. So this is considered as a finite set. Days in a week, only we know 7 days, right? So only 7 elements for the set days in a week, right? So these type of sets we can call finite set, right? Now just imagine there is a set A. It set A such set A is a set of X such that X is a X is a even positive integers, right? So even positive integer means for this set, we can starting from 2, 4, 6. I don't know how many elements it until it will goes to stop this set, right? So these type of sets we can call infinite sets, right? Another example, they are telling I is a set, right? We need to find out the intervals between 1 and 2. Between 1 and 2, we need to find out some intervals, right? So it's up to your requirement, right? For I, someone says 1.1, Okay, one person says 1.0 to 1.1 as a one interval, 1.1 to 1.2 as a one interval. Sometimes someone says 1.01 to 1.0 to 1.02 to 1, 1.03. We don't know how many intervals exactly for these type of sets. So this situation, we can say this is a infinite set, right? This is infinite. We don't know exactly how many elements. If someone asks to define an interval between 1 and 2, it's up to your requirement, right? Maybe someone consider interval as a 0.1 range, 0.1 length. Someone says 0.01001, someone 0.01. It's up to their requirements, right? We don't know exactly how many intervals for these type of sets. So in this situation, we can say that is a infinite set, right? So finite set means maybe it becomes a empty sets, or maybe it becomes a uh, exactly defined number of elements. If you know the exactly how many elements belong to that set, we can say that is a finite set. Or if you know the set is an empty set, you can say that is also a finite set. Other all the sets are considered as a infinite sets. Yeah, months in year. That is a finite, right? Only 12 months. We know all the elements possible to that set, right? If you know exactly how many elements, we can say that's a finite set. If you don't know exactly how many elements for that, we can say that is a infinite set. Okay, now we will look at uh, counting elements in the set. If you have a set, how we can count the elements, right? Sorry, yeah. Yeah, before moving to that, so now we know what is finite. Sorry. Now we know what is finite set and infinite set, right? Another concept, countable and uncountable sets, right? Another concept, countable sets and uncountable sets. Now we will look at what is countable set, what is uncountable set. Now you are clear with what is finite and infinite, right? If you know what is finite, then only we will find out what is countable sets, right? Now we will look at what is countable sets, right? If any sets it all if any set it is a if any set becomes a finite set, we can say that is a countable sets, right? How you can find out the countable set? You need to check whether this set is a finite set or not. If a set is a finite set, then we can say that is a countable set, right? If any set becomes a finite set, then we can say that set is a countable set. So how to find out? If any set becomes a finite set, we can say that is a countable set. That is one type. We will find out the countable set. Another way, they are not a finite set, but the elements are in a sequential order, right? The elements are arranged in a sequential order. Then we can say that is a countable set, but it is infinite, right? So already we discussed finite set and infinite set. So how you can find out finite set? If the set has empty set, or if the set has no elements, if any set becomes an empty set, we can say finite set. Or if a set has exactly a particular number of elements, if you know how many elements exactly belongs to that set, then we can say that is a finite set. To find out the countable set, it must be a finite set. So in countable set, we have countable set. We can say if it is a finite set, it becomes a countable set, right? Another situation, this is the set that is not a finite set, but the elements are in a set in a sequential order, then we can say that is countable infinite set, right? So countable set means it must be a finite set. Then only we can say that is a countable set, right? You have a set that is not a finite set, but they have a sequential order. The elements are arranged in a sequential order. Then we can say that is a countable infinite set. All other sets are, we can say, uncountable sets. Right? Did you get my point? Is it clear or need to explain more again and again? Tell me. You need to differentiate what is finite set, what is infinite set. You need to differentiate what is countable set and uncountable set, or what is countable infinite set. You need to differentiate these things. Okay, I will explain again, right? So yeah, so just summarize the things, then you can easily understand, right? Also, you can remember one example, then you can easily understand, right? So we already discussed finite set and infinite set, right? So finite set means if any set, an empty set, if any set as an empty set, it means they don't have any elements, it becomes a finite set, right? Or if any sets, they belongs to a particular number of elements, let's say uh, days on a month, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? So this set belongs to a finite set. So finite set means they have exactly a particular number of elements. If you know the exactly how many elements belong to that set, or if a set is an empty set, we can say that is a finite set. All other sets are considered as an infinite set. So even number, right? Positive even number, that is an infinite set. Why we are saying positive even number is an infinite set? So positive even number means that set start with 0, 2, 4, positive even number, right? So it is a 2, 4, 6, 8. It will goes until infinite, right? So this is we can call infinite set. Infinite set. Countable means we are counting the elements, right? We can count the elements, right? Is it possible to count these elements? But here we can count the elements 1, 2, 3, 4, 5, 6, 7 elements, right? So if a set becomes a finite set, it considers a countable sets, right? If it's a finite set, we can say that's a countable set. But in countable set, we have another category, category, countable infinite set, right? Another category called countable infinite set. Countable infinite set means countable infinite set means that is an infinite set, but the elements are arranged in a sequential order. What do you think about this example? So countable infinite means the set becomes an infinite set. So this is also an infinite set. Now you need to check the elements are arranged in a sequential order. What do you think? Is it arranged in a sequential order or not? So the elements are arranged in a sequential order here, right? Each elements added by plus 2, right? This is arranged in a sequential order. So we can say this is a countable infinite set. All other sets are, we can say, uncountable sets. These are the concept, right? So we can divide two sets is a finite set or infinite set. Finite sets means they have a specific number of element, exactly n number of elements, or that's if a set is an empty set, we can say that's a finite set, right? To become a countable set, definitely it must be a finite set, right? If a set is a infinite, but the elements are arranged in a sequential order, then we can say that is a countable infinite set. All other sets are uncountable sets, right? So infinite set means infinite means you need to check whether the set is a finite or not, right? Infinite means you cannot find out how many elements exactly for that set. That is infinite set. Infinite set means we don't know exactly how many elements belong to that set. If you look at the positive integer even number, we don't know exactly how many elements for that one. Without any boundaries for that set, we cannot say, right? Now someone says A is a set. A is a set of X such that X is a positive even number, right? And X between uh, greater than 0 and 15. Now, what do you think about A? What do you think about set A? Is it, now tell me, is it finite or infinite? What do you think? A is a set of X such that X is a positive even number, and I am giving a boundary for X. So greater than 0, less than 15. So how many elements? If you know how many exact elements for this set, we know, right? We know exactly how many elements for this set. So positive even number means above greater than 0 means 2, 4, 6, 8, 10, 12, and 14, right? These are the elements. So we know exactly how many elements belong to this set. Then we can say A is a finite set, right? What do you think about countability of this set? Whether it's a countable set or uncountable set or countable infinite set. What do you think? If any set becomes a finite set, we can directly say this is a countable set, right? Yeah, very good. So if any set becomes a finite set, definitely it becomes a countable set, right? If any set, we can say it's an infinite set, then only you can check whether it's a countable infinite or else, right? How we can check if any set is a infinite set, then you can check is there any sequential order. The elements are arranged a sequential order, then we can say that is a countable infinite set. All other sets we can say uncountable sets. These are the theories behind these finite and countable sets, right? Okay, now complete this until this portion, right? Okay, now next we will look at, okay. Now we are look at what is finite set, what is infinite set, what is countable set, what is countable infinite set, what is uncountable sets, right? Uncountable means that is not a countable set. Also, even if it is a uncountable set means that is not a countable set. How we can check countable set? If that is a infinite set, we can say that is not a countable set. Even if it is an infinite set, you need to check is there any sequential order. The elements are arranged in any sequential order or not. If the elements are arranged in a sequential order, we can say that is countable infinite set. Otherwise, we can say that is a uncountable set, right? Now we will look at how we are count the elements of a set, right? Let's say you have a set A, it contains elements A, E, I, O, U, right? Now we know this is a finite set. Why? We know exactly this set has only 5 elements, right? So this is a finite set. So if it is a finite set, we can say that is a countable set. Now we need to count how many elements this set has. So now we need to count how many elements in the set. To denote this one, we are using n number of A, right? So if you look at this type of symbol here, uh, n within the parentheses, you are writing the name of the set. It says number of elements in set A, right? So if you look at this symbol, you need to understand it explain number of elements in the set A, right? This is explained by this symbol, this notation, right? Number of elements in set A, right? Now tell me what is how many elements? 1, 2, 3, 4, 5. So it is equal to 5, right? This is the way we can count the element, right? Now tell me, what do you mean by this? What is the answer for this one? What is the answer for this one? What is this? This is a symbol of, tell me what is the answer for this? If you understand up to this, you can answer my question. So if you put n within parentheses, if I write a letter, set of A, it explained by number of elements in set A. Similarly, if you look at here, what is the answer for this one? Tell me, everyone. Yeah, very good. Some of did the correct answer, right? So number of elements is an empty set is equal to 0, right? If it is an empty set, they don't have any elements, so we cannot count, right? So the answer is become 0, right? The number of elements is an empty set, it is equal to 0, right? Now tell me, you have a set B. Okay. Uh, days in a month of January. Tell me. So what is the number of B? Number of B means what? So days in a month of January. Always January, how many days? So the elements are starting from 1 to 31, right? January have 31 days. So how many elements? Number of B is equal to 31, right? So this is the way we can count the element, right? Do you have lectures at 10:30?
Yes. Yes, sir.
Okay. So hereafter, if you look at this symbol, right, you need to find out there is a set X. They are asking how many elements in the set X, right? They are asking throughout the symbol, they are asking how many elements in the set X. There is a set X, how many elements they are asking throughout this symbol. Okay. Now previously we are discussed disjoint set, right? So let's say there are two sets A and B are disjoint. Okay, there are two sets A and B are disjoint. What do you mean by A and B are disjoint means? Tell me. We already discussed. If two sets are disjoint means what? If I write this sentence in whatever the questions, what is the conclusion from this sentence? If I tell this sentence in any questions, what did you conclude? What is your uh, understanding from this situation, from this sentence? If I mention this sentence, A and B are two sets and they are disjoint, there is no common elements between A and B, right? So if there is no common elements between A and B means what? So we can write as a symbolic way, if there is no common elements between A and B means A intersection B is equal to null, right? So if I ask a questions, there are two sets A and B. The A and B are disjoint. Now I am asking this one. Now, what do you mean by this? So I'm asking you, A and B are disjoint sets. So now ask number of elements of A intersection B. So what is the answer for this question?
0.
0. So the answer is 0, right? So how you can find out if two sets are disjoint, we know the intersection of these two sets are empty, right? There is no elements, empty sets. That is an empty set, right? Now they are asking how many elements in a set A intersection B. There is a set A intersection B. They are asking how many elements in this set. So if it is an empty set, the number of elements are 0, right? So we can find out the answer, right? Okay. In the same situation, A and B are disjoint sets. Now I am asking number of elements in the universal set. What is the answer for this one? Now I'm asking you, it means I don't know exact value. How you can find out the number of element in the universal set? Oh, just okay. Before telling this one, now tell me number of elements in A union B. How you can find out the answer? So A intersection B, if it is A and B are two sets, A and B are disjoint, we know the intersection is 0, right? The intersection between these two sets are 0. Now, if someone asks what is the number of elements in A intersection B, that is 0. Now tell me what is number of how many elements in A union B? How to find out? How to find out? If you don't remember the equation, just plot, right? Just plot a diagram, right? If A and B are disjoint set means there is no intersection between A and B, right? So now they are asking, so if you look at this diagram, you can say the answer A union B. If each set A and B are disjoint, so the A intersection B is 0. There is no intersection, right? Similarly, A union B is what? A union B means you need to get all the elements of A and all the elements of B. So you need to find out number of A plus number of B, right? This is the equation to find out number of elements A union B, right? Yeah, very good. Someone say the correct answer, right? When it will possible, A and B are disjoint sets, then only you can say A union B, number of elements in A union B is equal to number of A plus number of B. What is the condition? A and B are disjoint sets, right? Otherwise, you can't say this way, right? Why I can say this way? Just look at here. You have two sets A and B. They are not disjoint set. Now tell me A and B. Now number of elements in A intersection B means you cannot say it is a 0, right? Why you cannot say it's a 0? There is some common intersections between these two. So you need to find out how many elements in this set. So that is the answer for here, right? Similarly, number of elements in A union B means what? So at the time, what will happen? Just look at here. Just look at here. If you consider number of A plus number of B means what will happen? So if it is a number of A, just look at here. Number of A means we are consider this one as a number of A, right? This is number of A, right? Similarly, if I add number of B means what will happen? Number of B means okay. I put this one as a green color, right? For number of B as a green color and number of A as a orange, right? If I look this way, what will happen? Now tell me, is it correct? Number of A union B and consider number of A plus number of B. Is it correct? Wrong. Why? If I uh, if I add number of A plus number of B, what will happen? If you notice something here, this area is added 2 times, right? This area added 2 times. Do you agree with me? One time with green color, one time with orange color, right? So yeah, there is a duplicate of the intersection, right? So now what I need to do, I need to subtract, I need to minus one intersection, right? Then it's correct. So now what will happen? I need to subtract number of A intersection B, right? Sorry. I need to subtract A intersection B. Now the equation says number of A union B is equal to number of A plus number of B minus number of A intersection B. This is the common equation to find out A union B, right? If A and B are disjoint, then we can say number of A union B is equal to number of A plus number of B minus 0. Why? If A and B are disjoint, A intersection B is 0. So we can write as a this as a equation only if A and B are disjoint sets, right? Understand? Yeah, someone asked a question, right? Number of A union B is equal to number of A plus number of B minus A, B difference A. You're asking which situation? It is a You're asking on the normal procedure or disjoint condition? Tell me. Okay, someone asked a question. Number of A union B is equal to number of A plus number of B difference A. Okay, we will consider normal situation, right? Okay, yeah, they're asking that question, right? They're asking number of A union B is equal to number of A plus number of B difference A. So how you can find out? Just you can plot the diagram, right? So this is A, right? This is A, this is B, right? Number of A means all the elements belong to this one, right? All the elements belongs to this entire circle, right? Entire circle. So B difference A means what? B difference A means, tell me, from B, you need to remove this area, right? So let's say I plot here, right? Uh, this is B, this is A, right? Then B difference A means from B, we need to remove A, right? So this portion is B difference A. So now here B difference A means this portion, right? It's correct, right? It's also correct. This is the way we can find out, right? So A union B means you need to find out all the elements from these three areas, right? So it's correct. Yeah. So easiest way you can draw and find out the answer, or maybe you can assume some sets and you can check whether it's correct or wrong, right? This is correct, right? But the previous case, number of A union B is equal to number of A plus number of B minus number of A union, A intersection B is a equation, right? This is a theoretical equation, right? Similarly, if you need number of A intersection B, how you can find out? Number of A plus number of B minus number of A union B, right? I can change the subject, right? So this is the equation. From this equation, I will take some others. Number of A union B is equal to number of A plus number of B minus number of A intersection B. If I move this one here and this one here, this is the equation. Number of A intersection B is equal to number of A plus number of B minus number of A intersection B, right? So if it's up to your requirements, you can change the subject, right? Okay. Now think about, we already discussed disjoint union, right? Disjoint union. What is that? Disjoint union mean, let's say you have two sets, right? Maybe this is your universal set. This is set A. This is set B. This is universal disjoint set. Disjoint set means, so this area we can say as A. This area we can say as a B, right? Disjoint union means what? We already discussed, right? Disjoint union, set S is a disjoint union means the universal set S, disjoint union means the set S is equal to the A plus B, right? This is, we already discussed disjoint union. Disjoint union means we are getting the sum of all the sets, right? Maybe we discuss while we are look at that product of sets. Disjoint union means we can say the set S is equal to, okay, if you need to find out the number of elements in set S, we can say number of elements in A plus number of elements in B, right? It must be a disjoint set, right? They are mentioning, clearly mentioning A and B are disjoint set. So disjoint union of A and B, we can say as a number of elements in A plus number of elements in B, right? Okay. Yeah. This one just you can read and understand, right? They are explaining the uh, A union B, the elements of A union B. They are explaining as a paragraph, right? Just you can read and understand. There is nothing to worry about this one, right? It's a simple one. So just you can read and understand this, right? Okay. We already discussed A difference B, right? Now, I think you know what is A difference B, right? Tell me, A difference B is easily just plot a diagram, Venn diagram AB, right? A difference B means what? A difference B means from A, you need to uh, you need to subtract this common area, right? That is, we can call A difference B. So from A means the entire circle. From A, we need to minus A intersection B, right? It says this area, right? A difference A minus or A difference B means this area, right? A minus B means this area, right? From A, we need to calculate the intersection. So if you need to find out the number of elements in A difference B, A minus B, we can say number of elements in A minus number of elements in A intersection B, right? Sorry. Yeah, number of elements in A minus B. So the number of elements in A difference B is equal to number of A minus number of A intersection B, right? So it's up to your requirements. You can create different equations, right? Okay, they are giving an example, right? They are giving an example, right? For example, suppose an art class has 25 students, right? 10 of them are taking biology class B. Then the number of students in class A which are not in class B, right? Just imagine, let's say there is there is a class A. The class A contain 25 students, right? They are mentioning class A contain 25 students, and among these 25 students, 10 students are taking the biology class B. So this is a class B biology class. 10 students are taking the biology class B, right? Now we need to find out the number of students, right? They are asking us, we need to find out number of students. So n number of students in class A which are not in class B. So what they are asking? A difference B, right? They are asking. So in A is a set of class A, right? Among class A, in the class A 25 students, among the 25 students, 10 students are belongs to class B. It means there is a class B, the students taking biology subject, right? So 10 students are belongs to class B as well, right? They are asking how many students in class A which are not taking class B. Not taking class B means what? They only belongs to class A. So if you look at this area, they are asking this area, right? So it means what? A minus B, right? So A belongs to what? The students in class A plus this area, the students in class A and B, right? So we need to find out only the students are belongs to class A, not in class B means this colored area we need to find out, right? So it means they are asking what is number of A minus B. To find out this number of A minus B, if you know the equation, then only you can apply, right? So what is the equation? Number of A minus number of A intersection B, right? So number of A, we already know they are giving in the question 25, right? Minus, what is the common? What is the common elements? The 10 students taking, I put this way, right? So the 10 student taking not B, right? The 10 student taking class B as well, right? They are just look at the sentence here. They are using and, right? They are saying suppose an art class A has 25 students. So I did everything and I explain again, right? You have a class A, you have a class B, right? They are mentioning as a class A has 25 students. And just look at here, N means they are considered, and 10 students are 10 of the students are taking biology class as well, right? 10 students also taking biology class, right? So the common elements for A and B is 10, right? So there is a set A with 25 students, and among the 25 students, 10 students are taking biology class, biology subject as well, right? So now number of A is 25 minus the common that consider as a class A and they are considered as a, they are taking class A, art class, and as well as the biology class, they are 10 students. So A minus B is 15 students, right? This is the answer. Okay, give me a minute. I will stop the class here. Yeah, I will share after the lectures. I will share the slides. Don't worry. Also, I will conduct the lectures on Friday, right? That is a fixed schedule, right? I will take the lectures. If I didn't take, I will inform you, right? Otherwise, I will continuously take each Friday, 10:30 to 12:30, right? Okay. Now, maybe just imagine you have a set A, right? Only you have a set A. That is a universal set. Now I am asking you, what is number of elements of A complement? How to find out? Now, number of A complement, number of elements in A complement, how you can find out? So you need to find out all the elements in this area, right? So this is first, just you can draw a Venn diagram and find out which area I need to find out, right? So here I need to find out number of elements in A complement. How I can find out? How I can find out? I need to find out how many elements in the universal set. So universal set means altogether we can say this is a universal set, right? From the universal set, I need to subtract the elements of A, right? So then I can find out the number of elements in A complement, right? This is one equation to find out the number of elements in the A complement, right?